Hello everybody and welcome back to another episode of Math with Mr. Emond. Today we are going to be looking at our last section in our unit on absolute value and reciprocal functions. Today we're looking specifically at reciprocal functions. Let's go through what they are. So hopefully you remember that the product of a number and its reciprocal, it's always going to be equal to 1. So for example, if you have the number 3/4, 3/4, its reciprocal is 4/3. Reciprocal is when the numerator and denominator swap places, right? So when you multiply 3/4 and 4/3, you end up getting 1. Because 3/4 times 4/3 is going to equal 12/12, which is 1. So anytime that you multiply reciprocals with one another, they're going to be equal to 1. Let's see how this applies to the unit we're currently working on. So let's look at example 1. Here we're being asked to compare the graphs of a function and its reciprocal. And what it's asking us to do is to sketch the graph y equals f of x and its reciprocal function. So f of x has become the denominator. So 1 over f of x, it would be the reciprocal of y equals f of x. And they're telling us that the function of x that we're looking at, f of x, is actually just x. And we know what that looks like. F of x equals x is just y equals x. And that's going to be a line, right? So let's go ahead and draw our line. Let's use a blue color. And this is a line that's going to be diagonal going through the point 0, 0, and going right into our corner. So it's going to look something like that, right? That's our line y equals x. And let's go ahead, even though we probably don't need a table of values for y equals x because it's a very easy one, let's go ahead and do it. So when x is 10, what's y? Well, or negative 10, what's y? It's negative 10. I mean, they're all the same, right? Because y equals x. So all of these values are exactly identical. I don't have to think very much here. They are the same. Okay. Now we want to graph our reciprocal function of this. So let's label this. This is f of x. We're going to want to label our reciprocal function. Now generally, what I like to do is if I call my original function f of x, then my next function that I'm going to draw, I'm actually going to call it g of x. Okay, so rather than y equals 1 over x, you might see me doing something like g of x equals 1 over x. And I'm going to tend to use different colors as well just to make things a little bit smoother. Okay, let's go ahead and fill in this next part of our table where we're doing our reciprocal values. Remember, our reciprocal values for this new function g of x is going to be the reciprocal of our original function f of x. So what's the reciprocal of negative 10 over 1? Well, the reciprocal, when you swap the numerator and denominator, becomes negative 1 over 10, right? When these swap places, you end up with negative 1/10. So what's the reciprocal of negative 5? Negative 1/5, right? This is 5 over 1 and it becomes 1 over 5. Reciprocal of negative 2? Negative 1/2. Reciprocal of negative 1 over 1 is just negative 1. Reciprocal of this, remember these are going to swap places, so this is going to be negative 2. So the reciprocal of negative 1/2 is actually negative 2. Likewise, this is negative 5 and negative 10. Now what's this? What's the reciprocal of 0? Well, let's just see what happens when we plug it into our equation 1 over 0. That's undefined. Okay, that's undefined. Reciprocal of 1/10 is 10, 5, 2, 1, 1/2, 1/5, 1/10. So we're just taking the reciprocal values here, right? And if you're ever getting a little bit confused as to how this is happening, you can just take this x value, like this one here, -10, put it as your x value in this, and it becomes 1/10. In this case, it's -10, so 1/10, which is -1/10. So now we can go ahead and try to sketch the graph of this one. So something interesting happens. At x equals 0, it's undefined. So what happens? What did we learn happens when something is undefined? You end up with an asymptote. So let's go ahead and draw in our asymptote at x equals 0. I'm going to fix that in a second. I'm just going to slide it over so it's right on top of our y equals 0, and I'm actually going to make it dashed because normally when we draw in asymptotes, it's dashed. So there, this vertical dashed line means that my x is not allowed to equal that for my new function, right? And let's go ahead and start plotting in some of our points here. So we have at x equals -1, y equals -1. So when x is -1, y is -1. Well, those are the same points, aren't they? That's interesting. Let's look at when x is 1, y is 1. Again, those are the same points. So the fact that our g of x and f of x points are the same means that these points are invariant points. I started with them for a reason, right? Because I've seen these functions before. Let's try some other ones. When x is -2, y is -1/2. So when x is -2, y is -1/2. Okay, let's try -5 and -1/5. So -2, 3, 4, 5, and -1/5 is going to be something like that. So I can kind of see as my x is getting smaller, I seem to be approaching 0. Let's see what happens when we get all the way to -10. It's -1/10, which is like super close to 0, right? There you go. And so now I kind of want to see what happens when it's a fraction, right? Let's look at -1/2. Y value is -2. So when x is -1/2, y is -2, which would be right there. So I'm starting to see, it looks like there's like a curve here. And I'm pretty sure it's not going to cross this because it's an asymptote, right? So let's try -1/10 and -10. So -1/10, where is that? I don't know. It's like really close, and -10's down there. Okay. We also have -1/5 and 5 right there. So now we have part of our graph, right? It goes through this point. Oh, I'm not drawing very well. I'll try to do this a little better. Goes through this point and that point, and then comes down, and it never touches your asymptote, which is your vertical asymptote is x equals 0. But notice we're also never touching here, right? So that's going to kind of tell us that most likely there's actually another asymptote, right? And there is. In this case, our second asymptote is actually x equals 0 as well. And again, I need to make that into a dashed line. So give me 1 second to do that. And let's make it a dashed line. And there we go. We have our two asymptotes. And I'm going to go ahead and actually label them. So my vertical asymptote is at x equals 0. And my horizontal asymptote is at y equals 0. So I have this horizontal line at y equals 0, and that's why we call it our horizontal asymptote. And I have this vertical asymptote at x equals 0 because it's a vertical line. Okay, so we have this side. What happens when x is positive? Let's go ahead and take a look at those. So we have this point, 1, 1. We have the point 2 and 1/2. We have 5 and 1/5. And we have 10 and 1/10. So again, it looks like it's approaching 0, but it's never going to touch it no matter what happens. We have positive 1/2 and 2. We have positive 1/5 and 5. and positive 1/10 and 10. So again, same thing's kind of happening here. It's going to get close to the asymptote, but it's never going to touch it. Let's try to draw this. It's really hard to do this on a tablet. So let's try it again. Going through our points. And there you go. It's the best that I can do here. And so the red, what's in red here, is my g of x. My blue is my f of x. And now I have graphed the reciprocal of my f of x function. What do you notice? There's horizontal and vertical asymptotes, right? And all of these y values is basically their reciprocal, right? So the reciprocal of 1/2 is 2. The reciprocal of 2 is 1/2, okay? And that's basically how you get this. And it ends up with these odd shapes that are isolated to specific quadrants. Let's look at the characteristics of this. So here's the graph, all nice. This is a computerized version from the graphing calculator. So what's the domain of this? Well, the domain of this is going to be x. Let's use the right colors because we're talking about f of x right now. So this is blue. The domain of this line, our blue line, is x such that x is an element of real numbers, meaning it's every number. There's no restrictions on our x. What about our range? Well, there's no restriction on our range either, right? So it's y such that y is an element of real numbers. Okay, so let's take a look at the end behavior now. So what's happening to our line here? Well, what's happening is as x is bigger than 0 and x gets very large, what happens to y? Y gets very large. Okay, so as x becomes very large, like think about when x is 1,000, what's y going to be? 1,000. What about as x gets less than 0 and x gets very small? Well, y is going to get very small. Okay, what's the behavior at x equals 0? Well, y equals 0. What are the invariant points? Well, okay, so let's think about the invariant points. That's comparing f of x to g of x. So what are my invariant points? It's there. So -1 and -1. And what's the other one? 1 and 1. And these are the same for both of them because obviously we're comparing the two graphs. All right. Let's look at the domain for our reciprocal function. Now we have some restrictions this time. What's the domain? Well, it's x such that x cannot equal 0. And apart from that, x can be anything. So x is an element of real numbers. That's really the only restriction, isn't it? X just can't equal 0. We have that asymptote there. What is y? Well, it's y such that y cannot equal 0. We have this asymptote, right? We're going to get close to 0, but we're never going to touch it. But apart from that, y can be anything. And so that's how we write the domain and the range. What's the behavior? This one's going to get a little tricky, right? We're going to have kind of 4 things going on here. So as x becomes large, when x is greater than 0 and x is large, I'm just going to do capital L, so like 1,000, what happens to y? Y is going to approach 0. Y is roughly going to equal 0. Roughly, meaning not going to equal, but it's going to be super, super close. Okay. What happens when x is greater than 0 and x is small? Well, y is going to get infinitely large, or y is going to roughly equal infinity. It's going to get super big here. What happens when x is less than 0? So now we're on the negative side of it, and x is small. Well, y is going to reach, so look here, when x is really small, what happens to y? is going to be roughly equal to negative infinity. So it's going to get super small to the point that it gets near negative infinity. And when x is less than 0, but x is a large negative number, y is going to approach 0 again, but this time from the negative side. So that becomes really interesting. What's the behavior at x equals 0? It's undefined. It's undefined there. There's a vertical asymptote. And the invariant points, we got them. Okay. So now it's going to be your turn. What I want you to do is try to complete your own graph here. So you're going to need some graphing paper. You're going to sketch the graphs of your original function. Okay, sketch the graphs of y equals f of x when f of x equals 2x. So there you go. And also sketch the graph of g of x. So the reciprocal of f of x. And I also put that here for you. G of x is 1 over 2x. Go ahead and complete this table of values. You'll find it in your workbooks and graph it. We'll see you when you return. Okay, welcome back. Let's go through the solution. So the first thing you should have done is made your table of values. You can go ahead and check it with this, right? And you should have then tried to graph it. So your f of x is just a line, right? It's a line with a y-intercept of 0 and a slope of 2. So you can rise 2, run 1. Rise 2, 1, run 1. And that's how your line should probably get created when you graph it, right? It's in slope-intercept form here. And of course, you could have made a table of values. For g of x, what you're going to do is probably use those table of values. So you should have found that there's a vertical asymptote at 0 and a horizontal asymptote at 0. And then you start plugging in some of these values, right? So you end up with a graph that looks very, very similar to hopefully this. Whenever y equals 1, that's going to be an invariant point. So those are your invariant points there. And then plot your other points, and you can see my dots there. And that is it. Now what I want you to do is do the same thing that we did in our example. Here's your graph, and you should find the domain, the range, the asymptotes. Can x equal 0 for the two different functions? Can y equal 0? And what happens to the values of x at values of y as x increases or decreases in value? And what are your invariant points? Again, this is going to be found in your workbook, but if you don't have the workbook, just go ahead and copy these down, and when you are done, we'll check your answers. See you soon. Okay, welcome back. Let's go through the solution. So your domain for your line is all real numbers, and the range is all real numbers as well. It's a line, right? Asymptotes, there are none. Can x and y equal 0? You bet. What happens when x increases in value while y increases in value? And as x decreases, y decreases. And what are your asymptotes? They're these points here, and they're -1/2 and -1, and 1/2 and 1. And those are shared points. Now, lines, that's easy. Let's look at the reciprocal function and make sure we know how to do that. So x cannot equal 0 when x is an element of real numbers. There's a restriction. And on the range, there's a restriction of y cannot equal 0. These are your asymptotes. So what are your asymptotes? X equals 0 and y equals 0. Can x equal 0? No. Can y equal 0? No. What happens? Well, as x increases in value, so when x gets bigger, when x is greater than 0, well, y is going to approach 0. And as x gets bigger, when x is less than 0, y is actually going to approach negative infinity. What happens as x decreases? Well, again, there's two cases. As x decreases and x is still positive, it's going to reach positive infinity. And when x is decreasing and x is negative, y is going to approach 0. Okay, so that's it for this video. Stay tuned. In the next video, we're going to be looking at graphing linear reciprocal functions. See you then. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end, and over here, you will find the next video in this unit. Keep learning, everybody. Take care.